Hi dear students, I am Mr. Prabhu, faculty of Modoti Residence Center School Shikaripura. Today I am continuing the second chapter, that is polynomial. In the last class we are already studied the brief introduction about the polynomials. What do you mean by the polynomial? The classifications of the polynomial. So in this class we are going to study about geometrical meaning of zeros of a polynomial. Yes, you know that already. What do you mean by zeros of a polynomial? If the value of the polynomial is equal to 0, if any variable, the values of the variable goes to 0, that is known as the zeros of a polynomial. In this, we are going to study about what is their exact meaning by using the geometrical representation also. Yes, let us consider firstly linear polynomials. What do you mean by linear polynomials? The polynomials is an expression which having the powers of 1. The variables which contains the highest power is 1. So that is none other than the form is ax plus b or ax plus c. This kind of forms. This is the general form of the linear equations. Now let us consider one of the examples. Consider here 2x plus 3. In the last class we studied this one. So it's the relations. Always the value of k is directly related to the its coefficient as well as constant. That is any real number. Suppose k is a 0, then p of x may be also is equal to 0 because p of k is equal to 0. So what is its value and all it is studied in the last classes. Now take their geometrical meaning. What happened there? Zeros of polynomial. How you consider this? What is the exact meaning? Why it is important? So this is the question arises in our mind. So I want to clear by using this concept. How? Let us take one example. Let 2x plus 3 be linear. Okay, linear polynomial. In which, suppose you want to represent in graph, what happened? Then suppose you want to represent this polynomial in graph or graphical method. So then y is equal to 2x plus 3. That you know, always the graphical representation contains by using a planar paper, that is graph sheet or graph paper in which x and y axis. Okay. So now consider y. It is a graphical representation. For graphical representation, you know that the tabular column. That is how consider it is x and it is y. Now let us assume. For example, take x values. That you know at what value x equal to means at what value at x values comes 0. It means the polynomial becomes 0 at certain values of x. So here I want to take some values now. Consider minus 2 and 2. What happens its value? Y minus 2 into 2 minus 4 plus 3. It becomes minus 1. So what happens is next to 2 2s are 4. 4 to 3 7. Consider for graphical representation. Now assume suppose we are using the graph. Consider over here. Look 0. Just I roughly drawn over here. So it is the origin. Okay, it is an x. And it is an y. Okay, of course it is x dash and it is y dash. Always positive numbers, negative numbers. Positive number of x axis, negative numbers of x axis. Positive number of y axis, negative number of y axis. Look here, the points. How would you represent the points? X and y values. All x values are represented over here, y values are represented over here. So by using this, I want to compute first 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Positive integers. Here you can take minus 1, minus 2, minus 3, etc. Here also 1, 2, 3, 4, 5, 6, and 7. Because next minus 1. Minus 1 or you can take like this also minus 1, minus 2, like this also. Okay, instead of that, we can represent over here also. So, take how much the highest values. Okay, now by using this tabular column, now just I draw rough graphical representation. Now plot the graph. Plot the graph. Of course, you can use the graph sheet paper also. So now look here, minus 2 here minus 2, it's x-axis and y-axis. It goes to minus 1. It means the point comes to here. Okay, plot the point. 2 and 7, 2 to 7. Here it is 2, here it is 7. Approximately it comes to this. Okay, point. Consider the small digits are also there. There are 10 small digits along with the larger lines are over here, both horizontal and as well as vertical lines. So now just plot the graph. Of course, only 2 points I took over here. That is why only 2 points are plotted on the graph. That is comes the third quadrant and as well as first quadrant. Suppose you want to join it, so it comes look like this. It may be a straight line. It may be a straight line. Consider it is 2 minus 1. Consider it is 2, 7. Now, assume that if p of x is equal to 2x plus 3, so it is a polynomial, means linear polynomial, at which some variables, values of variables must be 0. So here the line appears here. For this linear equation, the straight line will be appearing. Okay, instead of this polynomial, you can take any linear polynomial also. Of course, it is look like a straight line. Okay, so whenever this straight line comes, observe carefully where it exactly passes. Of course, consider, just I imagine that one. In a graphical representation, it touches the x-axis and y-axis. Here it is between the half of this one, that is minus 3 by 2, comma 0. Here it is. Here it is 3, 0, comma 3. Because the coordinates of x and y, here it is y0, here it is x0. Here it is considered minus 3 by 2. Why I am mentioned? Because this straight line passes through the x-axis between minus 2 and 1. This straight line will passes through the point only on y-axis. That is why it is 0 and 3. But what we studied in the previous classes, that is, for example, if it is become a zeros of a polynomial, there will be a certain values at x may be equal to k value. Means the k must be 0. Means k is any real number. So that is why we imagine that here minus 3 by 2. Exactly, suppose you want to substitute these values in this equation, so you get the zeros of polynomial. What happened? Y is equal to 2 minus 3 by 2. So it is y is equal to 2x plus 3 means it is 2 into minus 3 by 2. This 2 to cancel, plus 3 remains. Therefore minus 3 plus 3 cancel. It is k. Therefore our p of x may be what happened? Really 0. It is a zeros of polynomial. Consider now linear polynomial becomes 0 because of this value. At what value? At x values. Consider this straight line will touches or it intersects the x-axis at certain points. Then their values are exactly 0. Means the polynomial becomes 0, whether it is linear or it is polynomial also. Now let us consider another example also. Look well, not only this one. So what happened for linear? In generally you can say if p of x be a polynomial, consider this ax plus c. Okay, where a is not equal to 0, so then the graphical representation which intersect the x-axis at which the polynomial becomes 0. Here only, suppose put these values, this is not become 0 because look here, 2 into 3, 6 plus 3, 9 it becomes. So it cannot go to 0. We require what is zeros of polynomial means by using the graphical representation like this only. Suppose you can take any values also. So that values if the line touches the x-axis, then only the polynomial becomes 0. That is why in general the linear equation or linear polynomial maybe a is not equal to 0. Then their values at the x-axis must be equal to 0. Hence it is zeros of polynomial. This is the graphical representation one. Consider what is the zeros of polynomial for quadratic. I mean, what is the zeros quadratic polynomial? What is its meaning? Now let us assume one example by using the graphical representation, that is geometrical meaning. So now let x square minus 3x minus 4 be a quadratic polynomial. Okay, here it is. So assume that now this x square minus 3x minus 4 be on graphical representation. Okay, look here, consider the same numbers, minus 2 and minus 1 and 0. You can even 1, 2, 3, 4 and lastly 5. Okay. And the last classes minus 2, minus 1, 0, 1, 2, 3, 4 and 5. Okay. So now put these values. It means in this equation, that is consider p of x become now y is equal to minus 2 whole square. Okay, minus 2 whole square minus 3 into minus 2. Okay, minus 4. So what happens? Minus 2 whole square means 4 minus plus become 6 minus 4. Okay, this 4 cancel 6. Here it is 6. Okay, next minus 1. Minus 1 square means 1 plus 1. Okay. Minus 3, it is minus 1. It becomes plus 1 plus 3 plus 3 minus 4. It means here it is 0. It becomes 0. This value is 0. So here 0. If it is 0, what happens? 0 square, 3 into 0, it is minus 4. 1 square, 1 square, 1 square, minus 3 into 1. 1 square means 1. It is 1. Minus 3 into 1, minus 3. Minus 4. What happened? 1 minus 7. 1 minus 7 means minus 6. Now its value is minus 6. Consider 2. 2 square. The same way. Consider 2 square. Okay. 2 square minus 3 into 2 minus 4. So therefore 4 minus 6 minus 4. This 4 cancel automatically. This is also equal to minus 6. In the same way 3 square. 3 square minus 3 into 3. Minus 4. 9 minus 4. This cancel minus 4. This is minus 4. Now 4 square. 4 square minus 16. Minus 3 into 4 12. Minus 4. Okay. Minus 16 plus 16. Automatically get cancelled. It becomes 0. Here it is 0. What about 5? 5 square. 5 square minus 3 into 5. Minus 4. So that is 25. 3 5 15. Minus 4. 25 minus 15 minus 10 means 10. 10 minus 4. It is equal to 6. Here it is become also 6. Okay. Just go through the graphical representation. That is, here it is x coordinate and as well as y coordinate. It is x dash and it is y dash. So now represent this. What kind of the graph will appear? Okay. Look here, minus 2 to 6 here. Minus 2 to 6 here, minus 1 to 0, here minus 1 to 0, so 0 by 0 to 4, so 0 to minus 4 here, next to 1 to minus 6, 1 to minus 6, next 2 to minus 6, 2 to minus 6, and 3 to minus 4, 3 to minus 4, next 4 to 0, 4 to 0 over here, and lastly 5 to 6, 5 to 6. Now draw the line. What kind of line will appear? So now look here, that is the graphical representation of this quadratic polynomial will appear look like a parabola. Consider it is a parabola. Okay, it is parabolic structure. Suppose you have using the graph sheet, exactly the point will appear. The structure of the graph will be in parabolic structure. It may be like this shape or this shape. That is considered as parabolic structure. Now observe carefully. So in which points? Consider all points are here. It is minus 2 to 6 over here, and it is minus 1 to 0 over here. Next one is 0 to 4 over here, 0 to 4 over here, and here some points are required here. 4 to 0 over here. Okay. Next 5 to 6 over here, 5 to 6. Okay. Next one here is 3 to minus 4. Okay. 3 to minus 4, and here 2 to minus 6, and here 1 to minus 6. Consider these coordinate points. At what value this polynomial, means this p of x quadratic equation minus 3x minus 4 becomes 0? Consider, just put the value of this only, minus 1 at x minus 1 square. So here already I written 0, means y value becomes 0. And next one 4. Only consider these two values. Why I consider? I want to make the polynomial become 0, means zero sum. I want to find the zero sum polynomial. So that is how, if you draw the graphical representation for that polynomial, then you are able to get only two values. Which are those? X at minus 1, x at 4. Only minus 1 and 4, you will get the polynomial value become 0. Here it is. Consider here it is. So that is why it says us, what is the zeros of polynomial for quadratic? It means if the polynomial, consider the general form of ax square plus bx plus g, where a is not equal to 0, then there the value of k must be some other real number. Then the value of x only, the value of x only is, the value of x only is become 0. Why? Look here, minus 1 and 4. Consider these values only. Why supposed to not consider for these all these coordinate points? Because they are not supposed to get the value of 0. Here it is Euler curve. In the same way, by trial and error method also you will be able to get some values. But by graphical representation, it appears like by previous example and the present example, we observed that any polynomial on graphical representation, whether it is linear, whether it is quadratic, and whether it is cubical, and any polynomial also, where their graphical representation, that is straight line or parabolic structure, if it intersect at x-axis, at that point only the polynomial becomes 0. So hence the total conclusion, we may say, let p of x may be any polynomial. Okay, any polynomial, either it is a linear or quadratic or cubical. Okay, so in such a way that the variables of the values and the graphical representation at x must be equal to 0. The values of x only become 0. So that is why this graphical representation, where they are intersected on the x-axis, then only we are getting the values of 0 of that particular polynomial. That is linear polynomial, quadratic polynomial, and cubical polynomial. Therefore, in the previous video, only one point. Here 2 points. Look here. This parabola touches the x-axis at 2 points, 2 distinct points. One is minus 1, another one is 4, at which the polynomial becomes 0. Hence, the conclusion is that for geometrical meaning of a zeros of a polynomial, it concludes that generally, consider a polynomial p of x, it becomes 0 whenever the graphical representation, on a graphical representation, the graph must be either straight line, either parabola, or any other structure. It should intersect at the x-axis, on which how many points will touch us. Based upon that, we can decide this number of points will become the zeros of polynomial, at which the polynomial become 0. Hence, that is considered as polynomial. Based upon these two examples, that is linear polynomial and as well as the quadratic polynomials, that you know how to represent on a graph, that is representation of a graph. Now consider the exercise problems which are given in your NCERT book. The first one says the graph of the y is equal to p of x, already they drawn, are given below. For some polynomials of p of x, find the number of zeros of p of x in each case. Then how many number of zeros are occurred or raised in the polynomials. That is how we can guess. So that is by your previous examples. That you know already the linear polynomial in degree 1. In the same way, the quadratic polynomial degree is 2 because highest power is 2. In the same way, cubical polynomial degrees is highest power is 3. In the same way, you can consider any polynomial. Depend upon their highest power, we should consider their degrees of the polynomial. So based upon that, here also already we drawn some linear and as well as quadratic polynomials graphical representation. Based upon that, if the graph is intersected at x-axis, then you decide at which and how many points it will touches or intersected. According to that, you can mention their zeros, means the points of the zeros. That is first consider here, in which the first figure here, the graph is right, maybe it is linear polynomial. So where it touches means where it intersected only at y-axis, not for x-axis or x dash. So that is why here it is non-zero. It is called as non-zero polynomial. For example, for a polynomial of p of x, the straight line will be appear on the graphical representation, so it cannot touch us or intersected on x-axis. That is why it is a non-zero polynomial. Now comes to the second one. We look here. So here these are some of the parabolic structure, semi of the parabolic structure, in which consider our x and y coordinates. Just this curve is touches only one point. Therefore, we have 1 0 means 0 of the polynomial become at one point the polynomial becomes 0. At one point only this polynomial becomes 0. Now consider here 1, 2, 3. 3 points. Therefore 3 zeros are here. Means at the 3 points the polynomial this polynomial becomes 0. Hence here also consider this is one of the graph. Okay. Consider it is also that is parabolic structure. So here it touches 2 points. Therefore it is 2 zeros of polynomial. Means 2 zeros. Here comes 2 0. Here comes 3 0. Here 1 0. Here none other than. It means what it says. The zeros of a polynomial depends upon the polynomial. Consider in general p of x. Okay. So that is if n number of points on the line of the x-axis, that is depends upon directly the degrees of the given polynomial. Degrees of the polynomial. That is why linear degree is 1, quadratic degree is 2, and cubical degree is 3. Based upon the degrees also, we can decide at 1 point, 2 point, 3 point, or another the points at which the polynomial becomes 0. Hence, the zeros of a polynomial study according to the geometrical representation and as well as the that is trial error method also. So instead of trial and error method, we are taking the geometrical representations. This is the one class. In the next class, we can relate the several relations between the quadratic and its polynomials. Thank you.